Okay, good morning, students. Today we are going to look at Laplace transform, and when we look at this example, it says prove that Laplace of Coshat is equal to s all over x squared minus a squared. And please, I want you to like and subscribe my videos. Follow me on YouTube. Thank you and God bless you. Okay, I'm going to show you how to prove this. It is not difficult. Is that clear? Just follow me on YouTube so that you will learn to know more. Amen. Okay, let's write solution. Solution. Laplace of cos 80 is equal to, that we should show, minus s squared minus a squared. Okay? Okay. I want us to know, how are we going to show that at the end of the day we will resolve to this? That is what I want to show you. Amen? It's okay. Okay. I want us to note something. Note that Laplace of cos 80 is the same thing as Laplace of exponential 80 all over 2, plus exponential minus 80. That is, it can be all over 2, or if you don't want it this way, this is the same thing as all over 2, because LCM, the LCM is 2. Is that clear? Okay. You agree with me, right? Okay. You know, before we can prove to obtain this, it means we are going to make use of this. Is that clear? We'll make use of this. I think with the help of this, I'll be able to prove and arrive at this answer. Okay, let's go. Now, we know that this is Laplace. This is Laplace. Let us define Laplace mathematically. You know, mathematically, Laplace is defined Laplace of f of t is equals to integral 0 to infinity exponential minus st f of t dt. Amen? This is the definition of the mathematical definition of Laplace. Okay, so if you agree with me, then let us still do something again. If you can see what I am saying here, amen? Okay, let me just open your eyes to know one thing. If assuming we have a plus b all over 2, note that this is the same thing as a all over 2 plus b all over 2. Do you agree with me? Okay. If you agree with me, then what if now we have Laplace of a plus b all over 2? Amen? Then agree with me that this is the same thing as either Laplace of a all over 2 plus b all over 2. Close bracket. It implies that this is the same thing as Laplace of a all over 2 plus Laplace of b all over 2. Do you agree with me? Okay. So if you agree with me, then let us look at this one. Is that clear? Let's look at this one. Okay. Let's look at this one. Okay? Yes. So if you agree with me, it implies that Laplace of exponential, because I'm going to solve it step by step for you to know and understand, so that you won't be asking unnecessary questions. Is that clear? Okay. So this, it implies that this is the same thing as Laplace of exponential 8 all over 2 plus exponential minus 8 all over 2. Amen? Okay? So if you agree with me, it implies that this is the same thing as Laplace of exponential 8 all over 2, then plus Laplace of exponential 8, minus 8 all over 2. Is that clear? Okay. You agree with me, right? Okay. So now, at this point, we are going to introduce the mathematical definition of Laplace transform. Look at it here. Recall this integral. Laplace of f of t. Now, here, our f of t is exponential 8 all over 2. So, we are going to substitute it here. Is that clear? Do you understand? Okay? So, if you agree with me, it implies that this will now be, this is equals to integral 0 to infinity, then exponential minus st dot. I told you that this is the function f of t, which is what? This exponential 80 all over 2. So instead of this f of t, we write this idiot. So we are going to have times 8 all over 2 dt. Is that clear? Then what we have here plus the same thing applicable because of this Laplace, this function, this Laplace. So we are going to substitute in the mathematical definition of Laplace transform. But take note that here, the function here, our f of t is now what? Exponential minus 80 all over 2. So our integral 0 to infinity is exponential, amen, exponential minus st times exponential minus 80 all over 2 dt. Is that clear? So now we can integrate this function. Are you following? So before we begin to integrate this function, I would like us to know something. I told you that I'm going to solve it step by step so that you understand it better. Is that clear? Okay. Now, if you can see what I am saying, look at the two integrals. Look at the two integrals. If assuming we have a raised to power n dots, a raised to power n all over 2, agree with me that this is the same thing as a raised to the power of n plus n all over 2. True or false? Do you understand? Because, why? Because we apply laws of indices. We apply laws of indices here. Laws of indices. Is that clear? We apply laws of indices here. How? Laws of indices. It states that if the bases are the same, we add the powers. True or false? But look at this base here. We have base a raised to the power of n times, this is multiplication law, a raised to the power of n. So since it is a multiplication law of indices, it implies that since the bases are the same, we add the powers. Is that clear? So if you agree with me, look at this integral. Is that clear? Are you following? Look at this integral. If you agree with me, if you can see what I am saying, it implies that This is the same thing as exponential minus st plus at, amen, 80 all over 2, true or false. Then this is the same thing as, let us factor out the t. So this will give us exponential minus exponential minus all in bracket minus a all in bracket t all over 2. Is that clear? The same thing applicable here. The same thing applicable here. This is the same thing as exponential minus st plus all in bracket minus 8 all over 2. It implies that this is the same thing as exponential minus st plus times minus will give us minus 8 all over 2. Then, if you agree with it, then here will now give us, let us factor out t. Here will now give us minus all in bracket s plus a, then close bracket t all over 2. Because if you use minus t to multiply this, you will still get back this. You use minus t to multiply plus a, you will still get back this. True or false? The same thing applicable here. So if you agree with me, this integral will now be this. Then this integral will now be this. Do you understand? Okay? So if you agree with me, let's solve it together. This is integral 0 to infinity. Please, Malians, take notes. Some of you don't know the difference between, you know that this is exponential minus s, open bracket s minus a close bracket t. But some of you will want to write it this way, exponential minus open bracket s minus t all over 2. Please take note. This and this, they are not the same thing. Is that clear? In mathematics. Is that clear? So please take note. Malians, take notes. Okay? Okay? So if you agree with me, it means we are able to reduce this to this form. We are able to reduce this to this form by using lots of indices, right? So instead of this, we will write this exponential minus all in bracket s minus a t all over 2 times the t. Then plus, let me take out this part, plus, amen, plus integral 0 to infinity, the same thing applicable here, exponential minus all in bracket s plus a t all over t to the t. Is that clear? So now we can integrate this function. Okay. If you agree with me, look at this integral. I want us to know something. You know that if we have notes that if we have a all over 2, this is the same thing as either 1 all over 2 times a. True or false? Do you agree with me? True or false? Okay, if you agree with me, then since we are integrating with respect to t, it means this half is constant. The half here, we have half here. This over 2 is half. The same thing here. So, without loss of generality, we can bring this half outside the integral. So, it means this will be in this form, integral 0 to infinity exponential minus all in bracket s minus a t dt. Then plus the same thing applicable 1 all over 2 integral 0 to infinity exponential minus all in bracket s plus a t dt. Is that clear? Okay. So if you agree with me, we can now integrate this function. You cannot integrate this function without having any problem. Now, you know that these are definite integrals. You agree with me? Why is it definite integral? Because we have here the lower limit and the upper limit. The lower limit is given as what? 0, while the upper limit is given as what? Infinity. So they are called definite integrals. Is that clear? So, okay, can I clean this part? Is it okay? Okay. It's not difficult. Just follow me up. Is that clear? Okay. So now, let us integrate this and integrate this. So, if we integrate this function, exponential minus open bracket s minus a close bracket t, since we are integrating with respect to t, it means this will give us, this is equals to 1 all in bracket minus exponential minus all in bracket s minus a t all over s minus a close bracket, then integral 0 to what? Infinity. Please, I know, Malians, you will not rewrite this integral again. Instead of this integral, for the fact that you have integrated it, you are going to write this integral, this form. Is that clear? Take note. I know some of you will go ahead and begin to write this integral this way again. Please, it is not right. Is that clear? And another thing, mistake some of you normally do is, for the fact that you are integrating, you know, some of you, anything integration, you integrate to obtain constant. You want to put plus the constant k or any alphabet. It is not so. Why? Because these are not indefinite integrals. These are definite integrals. So you cannot integrate to obtain constant. Is that clear? Because of the limit. Are you following? Okay. So if you agree with me, so we are able to integrate this function, obtain this. Then let us integrate this function. Is that clear? Plus 1 all over is constant. If we integrate this function with respect to this one with respect to t, we are going to have minus exponential minus all in s plus a t integral 0 to infinity all over s plus a. Is that clear? Okay. So if you agree with me, yes, here at this point we are going to subtract the lower limit from this upper limit. Is that clear? Okay, let us do so. Even we are going to do it here, also here. Is that clear? So now this is equals to 1 all over 2 open brackets minus all in brackets exponential minus s minus a, okay, a let's hold the t first, all over s minus a. Then you know we are supposed to write the t. I said we will subtract the lower limit from this upper limit. Is that clear? So for that reason, anywhere you see t, we must write the infinity. So we multiply it by infinity times infinity. Then we say minus, we write the same thing, all in bracket, minus exponential minus s minus a. Since this is the upper limit, we are subtracting the lower limit from the upper limit. So the lower limit here is what? 0. We are supposed to write t here, two of us. But for the fact that 0 is coming to replace the t here, so times 0. Is that clear? Close bracket. Then all in brackets Okay, can I take off this part? Can I take off this part? It's okay. No problem. Let me take off this part. Okay? It's not difficult. Okay? So, as I was saying, you are going to apply the same thing here. Here. What do we have here? Plus. We write plus. Are you following? Okay? Our half is constant. Okay? Then, on the lower, we subtract the lower limit from upper limit. Is that clear? Okay? So here will be minus exponential minus all in bracket s plus a. You know, instead of t, I told us we are going to do the same thing here. Instead of t, we will write infinity. Is that clear? All over s plus a. Is that clear? Then minus all in bracket minus exponential, the same thing applicable here, s plus a. Instead of t, we'll now replace it with what? 0. Is that clear? Okay, close the bracket. So now, here, this place, if you use this to multiply the infinity to multiply this, whole of this will give us 0. The whole of this thing. Is that clear? If you use infinity to multiply the whole of this minus exponential minus s minus a, all over s minus a will be 0. So if you agree with me, it means here we are going to have 2 all in bracket 0. Do you agree with me? Okay. Now, if you use 0 to multiply this, here will give us 0, right? So here will be minus all in bracket minus exponential what? 0. Close bracket. You close the bracket. Is that clear? Then plus 1 all over. Then the same thing applicable here. Is that clear? The same thing applicable here. Okay, so if you agree with me, here will be 0. Okay, here will be 0. The same thing applicable here because infinity is multiplying this. So the whole of this will be 0. 0. Okay, 0. Then, yeah, here the same thing is applicable here. Here will be what? Sorry, we do not put s plus this. Amen. We do not put s plus this. Okay, s plus a. Sorry, we do not put s plus a here. So now the same thing applicable here. Here will give us minus all in bracket minus exponential what? 0, right? All over. Yes, even here too, I made a mistake. Yes, sorry, here too, I did not put minus a. Okay, s minus a. Here too, yes, s minus a. Okay, thank you. Okay, so we are going to put s. Here we are going to put s plus a, right? Isn't it? S plus a. Okay, so here will be 0. Is that clear? Okay. So if you agree with me, okay, here will be what? Here will be 0. Use this one to multiply. Okay? 1 all over 2 all in bracket minus times minus will give us plus. Then anything raised to power 0 is 1. Is that clear? Here will be 1 all over s minus a. True or false? Then put the brackets. Then here the same thing applicable. Minus times minus will give us plus. Then anything raised to power 0 is 1. So here will be plus 1 all over the half. So if you use this one to multiply 0, minus times minus plus. So here will be anything raised to power 0 is 1, right? So 1 all over s plus a. Is that clear? Do you understand? Okay? So if you agree with me, it means, can I take off this part? Okay? If you agree with me, it implies that It means we are going to consider here. We are going to consider here. Let us multiply out. Or alternatively, if you can see what I am saying, you know that we have half here, we also have half here. So half is common here, true or false? Okay? So if you agree with me, we can factor out the half, then have it this way, s minus a plus 1 all over s plus a. Is that clear? Okay, at this point, we are going to take LCM. We will take LCM. The LCM of this s minus a and s plus a is the same thing as, let's have it in this form, the same thing as s minus a times s plus a. Is that clear? So this one, divide this one and this one will cancel. Remember, s plus a, true or false? So use it to multiply 1. It means, okay, let us write our half here. Let's have it like this. It means 1 all in bracket s plus a. Then what do we have here? Plus. The same thing applicable here. Use this to divide this and this will cancel. Remember, s minus a. 1 all in bracket s minus a. Is that clear? Close bracket. Okay? So if you can see what I am saying, this is 1 all over 2. Let us open the bracket. If we open the bracket, we'll have s plus a, because 1 times s is s, 1 times a is a. The same thing applicable here, plus s minus a all over. Open this bracket, s times s squared, then s times plus a as, minus a times s minus as, then minus a times plus a minus a squared. Do you agree with me? Okay? You agree with me? Okay? So, if you agree with me, I think I can take off these parts. I want to clean these parts, okay? Or, let me just do it here. Then, this is equals to 1 all over 2, 1 all over 2. Then, without loss of generality, this and this will go. It means we are going to add x plus what? S. Okay, for the sake of maths, let's still do it this way. S plus s all over this and this will go. We'll have x squared minus a squared. Is that clear? Okay. Then, do you need a prophet to tell you? You know that s plus s, just like 1 plus 1, it means it will give you 2. But for the fact that we have s here, it means just like s plus s, you bracket it. What is common? S. Then 1 plus 1. By the time you multiply this, you still get back this, true or false. Okay? So if you agree with me, 1 plus 1, 2. 2 times s. It will give us what? 2s. So the numerator will now be 1 all over 2, all in bracket, 2s, all over s squared minus a squared. Do you agree with me? Then this and this will go. Amen? So the final answer, therefore, is our Laplace of Coshat is equals to s all over. Look at the answer. This is equals to s all over s squared minus a squared. Is it difficult? This is how to prove this kind of question. Any question? Please like and subscribe the channel. Follow me on my YouTube, and I know very well that you understand mathematics more better. Thank you, and God bless you.